Hello, everyone. Thank you very much for joining today's webinar. We're going to discuss the software supply chain, the secrets, and we're going to focus a lot more on the risks we're seeing and the weak links that attackers are exploiting. So without further ado, my name is George Prichici. I'm one of the product leaders here at OPSWAT. I oversee our file security group that includes also application security and software supply chain. I'm joining from our office here in San Francisco, from the streets of San Francisco. So thank you much for taking the time. Now this is the main agenda for today, right? We're going to focus on some of the key elements on like how we're looking at the software supply chain market, like what are the risks, what's the threat landscape, what are the things you have to do, and is it just about SBOM or like things that you have to do past SBOM as well, and finally like final thoughts with best practices and so on. Before we start, a couple of things on OPSWAT. Our mission is to protect the world's critical infrastructure. And that means a lot more than just the SCADA, ICS environments, manufacturing, energy, and so on. It's what DHS defines as 16 different verticals from defense, government, local authorities, banking, manufacturing, energy for sure, nuclear, transportation, and so on and so forth. So any vertical, any industry you can think of, if it's going to disappear tomorrow, life as we know is going to disappear. So that's why like our focus is to pretty much secure all those highly sensitive environments. Now we've been on the market for over 20 years now. We have products that span from file transfers to secure file transfers, where we have most of the top 10 banks in US as customers, almost all nuclear facilities in US, a lot of defense projects, you name it. Any vertical that are part of those 16 that DHS define as critical are our main focus, and we have a lot of footprint there. Now, when we're looking at the SBOM market, like SBOM by definition is software bill of materials. So that actually means is if you're looking at a software, we're looking at its ingredients. What are the components in that software? What are the things that we should be careful when we're building that software, right? So for anyone that's doing product development, the rush is always we are behind the clock. We're trying to build as fast as possible that product. So we rely heavily on open source components, right? We're trying to reuse what actually the industry has built as almost best practice implementation and glue all those things together to move as fast as possible for us to deliver the functionality we need. Instead, for us to build everything from scratch, every line of code, we're picking up things that are doing a good job for our use case. Maybe they're like way bigger in scope than what we need, but we're going to use a subset of that for us to be able to deliver the functionality, right? And then as you bring in more and more of those components, we end up like having pretty much a recipe for success or disaster, depending on how those are going, right? And that's where you can see on the screen when we're looking at building that software is like we're building a pizza. You're looking at the ingredients and the risk associated with those ingredients. Now, in a nutshell, this is the definition of an SBOM, software bill of materials, a detailed inventory of all closed and open source components, libraries, and dependencies used in an application, right? And what actually this is, why is this important? You can see there is transparency, compliance, and risk management, which means a couple of things for us, right? It means that you're going to have that huge recipe of components, like that inventory of components, so to speak, right? And what is the risk associated with those ones? But for you to have a clear defined list, you need to understand what is behind the scene, because each component can have dozens, if not more, transitive dependencies on their own. So they can actually have an inventory of dependencies on their own as well. And you have to keep track of that one as well. Now, this is something became a global focus. You have a few of the definitions here from some of the main agencies that are defining how you should actually handle SBOMs at the part of your organization, but also as a product company as well. So you see CISA, you see NSA, you see NCSC from UK, but this is not just the US-UK initiative. This is something the European Union is regulating. There's something that it's a lot more part of ISO controls as well. You can see there like even Germany regulations and so on and so forth, right? So there's a lot more global movement in Five Eyes, Canada, Australia, New Zealand as well, but also part of NATO allied countries that are regulating, they're pushing for need for SBOM. And this is a huge response, if you want, as part of that Solargate that happened quite a few years back, and the mandate for us to have a clean view of like what we're actually consuming while we're either building or we're actually selling or even buying these products. Now, one thing I want to make a clear distinction is what is SBOM versus what is SCA. SBOM is the inventory of components, right? SCA on the other side, it's actually mapping those components to vulnerabilities, like identify vulnerabilities for those components, right? Now, the industry kind of like end up making almost like a merge between the two, but this how was originally defined, right? SBOM to have the inventory and SCA is the one that supplies the vulnerability management focus, let's say, of the SBOM. As a, let's say, as we're looking through the industry, there's a lot of attacks that are happening these days that are going after the product development cycle. And that means that's actually focused so deeply on the product development from threat actors is because every organization out there is trying to empower their product teams to move as fast as possible, for them to go and have access to the newest, best tools out there, for them to be able to produce faster, because they're always around the clock for them to deliver faster, new functionalities, new products, new deliveries. There's always more pressure to deliver than actually against their timelines, than actually time for them to spend for proper investigation. So then the threat actors are seeing as an easier path for them to walk into those organizations by actually compromising NPM packages or PyPI packages using typosquatting and so on, for them to be able to leverage that easy door in, let's say, is through the engineering cycle, for them to get access to compromised environments, get access to access keys, and so on and so forth. And there are a lot of attacks that happened in the last couple of months only, not discussed in the last years as well. Now, as a response to that, especially what happened in the last month or so, like let's say in the fall of 2025, right? Is there are a couple of like those three campaigns, like Shai Hulud was probably the one that made the biggest the news out there on like how rapidly it expanded and so on. So FS-ISAC published part of their event, in a couple of days ago. They published like a couple of recommendations on how to look at dependence, especially when it comes to NPM. But similar ones will apply for PyPI as well for Python, right? And we'll discuss a bit later on like how Python, how heavily it's being used part of the AI development, and how threat actors are kind of relying on that for them to get through typosquatting and other mechanisms in. But I just want to highlight a few quick things that are more procedural than technology focused out of their key recommendations, right? I like the one that the first one, consider treating all third-parties code as untrusted until validated by development and IT security teams. Now, we all know how unlikely it is that we're going to have someone in the IT team going through every small package, every component that the developer wants to use in their entire organization, especially in organizations where you have potentially hundreds, thousands, or tens of thousands of engineers. You're not going to have hundreds of thousands of IT professionals to go and validate each of those dependencies and so on, right? So that's not something you're going to do it in a manual fashion. You need a process for that in place and so on, right? Like, and this is where those speed bumps are coming into play. Instead, for you to be an early adopter of a new version for that software for you, or like a component, for you to wait a week or two to see if anyone else gets burned first, you shouldn't be the, I don't know, the first one, the patient zero, so to speak, right? So they're introducing like mechanisms or processes to like delay allowing engineers to use always the latest version and things like that. So like there are a couple of things that are being done at the repository level, like GitHub announced they're going to enforce MFA for repositories that are heavily being used and so on. But again, we don't have a lot of control over the open source that's being released. We can only have control while we're doing part of our environment. And this is like some of the best practices that are defined by FS-ISAC, part of the financial services information sharing, as I mentioned, on like how this should be handled. Now, the other part I want to focus on like how using AI and supply chain for AI became such a big vertical as well, like attack vector as well, right? So since everyone is pushed to adopt AI as fast as possible, they're literally in any business out there, there's as little as possible to know restrictions in using AI. Like threat actors started building these attack vectors where they're adding in the machine learning models, in the pickle files, even in open source libraries sort of used as part of the development for those processes or automation and so on. They added like malicious code. So I mentioned typosquatting before. You can see there's a lot of coverage out there on PyTorch and how everybody's relying on the fact that people might actually introduce a typo here and there, and they can pull the wrong library and they're going to deliver malware. Like pickle files, they actually embed malicious code and they're going to have full remote code execution on the engineer's machine, try to compromise it, get access keys, and so on and so forth, right? And this is where we need to harden those environments as well. We don't want to restrict the usage of our engineers, right? We don't want to limit their execution. We don't want to limit their abilities. The more you constrain them, the more security constraints the ability to execute, the more people are going to go around security, right? So we need to harden those environments or harden their processes so we can actually let them almost roam free, but at the same time have control over it. And we came up with like 7 kind of like weak links and like what we should focus on to address these needs. I'm going to go through them one by one in a bit more details. So on the open source and dependency risk, right? This is pretty much tying strictly to the velocity that we want to have. Nobody's going to have time to go and do a code review in every library that they're trying to use, right? Probably again, you're trying to solve something with a library that has, let's say, 5,000 lines of code, and you're going to use a 3% out of that to solve your problem. But you're not going to go and validate all that. As long as the functionality you're going after is delivered, you're happy. But at the same time, maybe those 5,000 lines of code have their own dependencies, which have their own dependencies and so on. And every library you're bringing in might bring 40 other dependencies next to it as well. And that's what you're seeing there with the transitive dependencies as well. So that continuous validation of those packages and monitoring on what you actually are using, it's so important. And keep in mind that even though if you're monitoring only at the top level, the libraries that you're directly using, importing, you might actually lose scope of like malicious code being injected in the transitive dependencies as well. And this is where it's so important for you to have a full scope of what you're actually using, part of your development or part of a product you're actually consuming from a third party that's actually more or less supplying you the SBOM, but they're supplying only for the top level. Then licensing risk, especially for product companies that are building applications, or for you that you're building on top of some of those commercial applications, it's so important for you to be able to like actually have license risks in place. This was something that was more of a legal, let's say, aspect in the past, but needs to be deeply embedded in the development process as well. When we're looking at licensing risk, it's so important for us to understand what actually is the risk associated with every library, right? There are licenses that allow us to use freely for commercial purposes and so on, but there are licenses that actually are forcing us to publish the software built on top of it on the same license, right? So some of them are actually viral. That means that if you're building an application and you're using an open source library that is GPL and it's forcing you to release everything under GPL moving forward, that means that the product you're using can actually, you might lose your own IP because it needs to be open source as well. So those kind of things are forcing you to actually make decisions on the future of your product based on the license risk associated with these libraries. And that's why it's so key for you to make sure the libraries you're using are compliant from a legal perspective and licensing perspective as well, right? So keep that in mind as you define, and this again, this should be a process for you to restrict on your development process to make sure that you're using up-to-date and compliant licenses as well. And there's a high chance, more and more likely these days, to be honest, where a license that was compliant, let's say 6 months ago or a year ago, the newer versions might be released under new license terms as well. So keep in mind, just because it was compliant a year ago, doesn't mean the license terms are not changing for that library. So continuous monitoring is so critical there as well. The next one is SBOM data gaps or missing SBOMs. So as I mentioned before, there are a lot more regulations regarding SBOMs, and some of them are actually mandating for vendors, let's say vendors selling to the US government are mandated to be able to share on demand their SBOM with the US government. Banking are asking for something similar as well, and so on and so forth, and became a bit of a, let's say, a weird mechanism on how those are being shared. So when it comes to like SBOM and sharing SBOMs, US government, for instance, mandated for vendors that are selling to US government to share their SBOM with the US government on demand. Same thing for banks and so on. They're following similar guidances or they're building their own requirements on that. But sooner or later, this needs to be top of mind for the vendors that are producing software. They need to be able to share their components and assume accountability for what they're using and how they're using. They might end up actually potentially losing, I don't know, let's say control over their contracts, or maybe actually lose contracts if they're not using compliant libraries and things like that. Now, keep this in mind that this is also a very tedious work, because even though they start having some standards on how SBOMs are being shared, some of these requirements are actually asking, give me an CSV or give me like a high level list for us to move on and so on and so forth. So there's a bit of tedious work there from procurement to actually vulnerability management on how those should be managed, right? So just because they're asking procurement doesn't mean that the vulnerability management team is not going to ask for a lot more details and so on. And that's the part which kind of like focus on like what is the data that we want to have in those SBOMs, right? And when we're looking at those ones, again, just having a list of components might not be sufficient. And each country started regulating what are the fields they are looking for. And I'm going to highlight a few things here as well, but there are things that are more and more important from a security perspective as well. Author is also important. Who are the contributors? Like, is there a new contributor? Is there like new source code, or like is there like new release that happened a few days ago from a brand new contributor and things like that, right? Like those should raise some flags, right? So that's why I mentioned the speed bumps that were kind of like start being as a potential mitigation for I don't know, new malicious components and so on. Like if something was released that it's malicious, let's wait for a week or two for things to cool off, for other ones to be patient zero, and if not, then we can actually consume it, right? But there are a lot more mitigation we can put in place if we understand better the data points here as well, right? Who is the author? If there are any additional suppliers, there are any additional dependencies, how often they're releasing? Is this something that's fully maintained, or it hasn't been updated in the last 3 years, and all of a sudden there's like a new contributor that's pushing to it and so on. So there's a lot of data points that can be leveraged to actually raise some of those flags as well, and that's something you have to keep in mind. Again, just having a CSV, which are the components, will not suffice from a mitigation perspective or like prevention perspective. Then let's look at third-party vendors, right? Because we keep talking about SBOMs from like building the product perspective, but in the same time, as the consumer of so many products, I want to make sure that my vendors are not compromised, and I want to make sure that whoever I'm working with is going to send me legit applications or legit code or legit components that I can use part of my product or part of my infrastructure, right? So a very similar process that we put together for open source, we need to put in process for all our third-party vendors as well. And this is something that actually is mandated in some regulations from ISO and so on, right? So like keep in mind, it's not just having a easy scan or keeping an inventory of application. It's actually, you want to make sure you understand the complexity in those applications. You want to make sure that they're actually sharing the SBOMs with you, and then you can actually control that. So like one of easy, really bad example, people are gonna hate me making that example, is Log4j. When that hit, everyone was scrambling to figure out, are we using it, where it's being used? I have like 1,000 enterprise applications. More than half of them are written in Java. Do I know who is using that one or not? Do I have access to that? Let me reach out to 500 different vendors for that product and version to tell me if they're using it or not. That's unmanageable, right? You need to have control, you need to have visibility to all that. And that's where like work with your vendors, collect that information, make sure they're giving you complete information, right? Back to the transitive dependencies. And then once you have that mapping, you can do a quick search, understand where this is being used and what's the risk associated with it. And where maybe you need to like lock down that environment or like pause that application for time being until you have a mitigation process and things like that, or assume the risk and so on. And one of my favorites that's growing quite nicely these days in coverage is the AI supply chain, right? And this is where you're seeing more threat models aligned with that. You're seeing more recommendations from OWASP, even NVIDIA's AI kill chain that define on how you can actually look at this one from data poisoning, from injection, and so on and so forth. So I recommend you guys checking that out as well. But I want to look at also from a supply chain attack as well, because most of our customers, or I feel like all companies out there, are trying to adopt AI as fast as possible, and everybody's going to the likes of Hugging Face and so on to download new models, to download new applications, to try out. They're seeing research papers that are very close to what they want, and they're trying to get that, I don't know, from GitHub or Hugging Face to try it out and see how that works and so on, right? And this is something that it grows so fast that actually it bypasses a lot of the restrictions we would put in place in a normal behavior, because you want those teams to move fast. And this is where the competitive advantage is coming in and so on, right? And you can see here, and there's a couple of research out there on like how some of the AI packages were being used in a malicious way. So this doesn't have to be just like the AI models or the pickle files. It can also be the libraries themselves. PyPI was down twice in the last year because there were too many malicious packages being uploaded. A lot of them trying to do typosquatting attacks, trying to mimic PyTorch, or having like a fork of PyTorch being republished with small differences there that were trying to hijack or like do some remote code execution and things like that in your environment. So keep that in mind as like you're empowering your teams to go and adopt this technology or test out and so on. How well are those being validated? Just because they're published on GitHub or Hugging Face and so on doesn't necessarily make it secure. So keep that in mind as an integrity check, a hash check if it's the right file downloaded, but doesn't mean anything. It just makes sure that the download process was successful, wasn't compromised, but doesn't mean what you download is secure. And this is the important part where it's a very big difference between downloading, let's say, an RPM package or something from a non-reputable approved source versus downloading something from the internet that anyone can contribute, anyone can build a spin-off of that one and publish it and so on, and claim great results as well. And then moving to like how you actually package these ones, and usually you're packaging like in containers and part of your microservice approach and so on. There's nothing novel about this one. Building an SBOM on containers, scanning the images, connecting your container registries and so on, right? And this is not just like scanning for vulnerabilities, right? Vulnerability scanning for containers was one of the hottest topics maybe like 5 years ago. But a lot of the industry moved from only doing vulnerability scanning to scanning also for like malware. There are a lot of containers that are published out there that have like malware, crypto miners, password sniffers, and so on and so forth. They're trying to like get in those environments again, leveraging that ease of use or like optimizing the user experience for your engineering teams. You end up in these situations. And moving forward, probably the last biggest topic that we want to discuss is secrets and credentials leakage, right? And this is what happens a lot, especially with teams that are moving fast. They're trying to like do all these kind of automations. You need all kind of like secret keys and so on to like bring environments up, put them down, have everything set up and so on. So you hard code some of those keys in your, I don't know, infrastructure as a code, in your source code and so on, for it to like run quickly those tests and so on to like move fast. And then you forget either to delete them, or worse, you just override that one and you recommit, which means two things, right? You can say, hey, I made sure there's no source code. In the source code, there's no access or credentials, access keys or credentials there and so on, but they're still in your Git history, and they're so easy to find in the Git history. And there are people actually even end up publishing on GitHub, like an open source with keys. And now GitHub has their own scanners and so on, and they're notifying you, hey, you published a key and so on. But at the end of the day, this should be part of your internal process to make sure those keys are not more or less in plain text, hard coded in your source code, infrastructure as a code, GitOps process, and so on and so forth, especially in your Git history as well, right? Because you're not going to see it, but it's hidden there, but so easy to find through a scan. And now one of the things I want to introduce is like what we're doing in this direction. So we introduced also like roughly a year ago Defender software supply chain, and this is the way we're looking to resolve the problem. We're trying to hook in every step of the CI/CD pipeline and to be more or less of an overlay on top of the CI/CD pipeline. And for us to solve more or less the three main problems we just discussed. One is SBOM with vulnerability scanning. The second one is malware scanning, and third one is secrets detection as well. Right. And when we're looking at that one, there are a couple of things I want to mention, right? Yes, it's very important for us to look from like a source code, container scanning, but also binaries perspective. Like we talked a lot about source code and building products and containers, part of that, but also vendor files, right? Like you're getting from you're getting products, I don't know, firmware updates, product installers, upgrades for those products, and so on, as part of your software supply chain, right? There's still vendors that are part of your supply chain. You want to make sure those are compliant as well. They should go through a similar checks as well as the open source or containers we define, right? And it's not just the vulnerability story, and that's kind of where we're trying to keep emphasizing. You can look at CVEs, but you should always look at like out of policy licenses, malware problems, secrets, and so on and so forth. So keep that in mind as part of defining this one, because everyone defines the vulnerability, part of the vulnerability management defines a vulnerability story, but they're missing, they have gaps in the other policies. And again, SBOMs, it's all about transparency, right? You want to have visibility, you want to actually understand what is being provided either by your product teams, what they're building, or either by the vendors that are supplying you with their products, and how those SBOMs are being shared, being either CycloneDX, SPDX, and so on. Or as I mentioned before, if they're CSVs, you're losing that visibility, right? They're transparent to some level. So try to push for more for you to be able to have that inventory that we were talking about. And this is part of like a quick screenshot. I'm not gonna spend too much time on it, like how we can actually build this like and have that visibility through the product, right? From not just from CVE's perspective and SBOM, but also from secrets and out of policy licenses, malware, and so on. And this is probably one of the main slides I want you like to have as a takeaway, right? You have already built, you invest a lot in your CI/CD pipelines if you have like you've built your SDLC, right? Instead of going and redefine all that and plug a product here, plug another one over there, change the workflow for all that one, and so on and so forth, try to add an overlay on top of all that to offer you the visibility, but also the enforcement when needed, right? So that doesn't mean necessarily that you're gonna go and control every step of the process by actually asking them to put everything, like asking the engineering teams to put everything on hold if you're doing validation, but you can hook into those places. And if the situation is that dire, you should lock it right there, and you should do the containment and instant response if needed, and so on and so forth. But it's not just visibility, it's also how you can enforce it without affecting the SDLC. And let's be honest, it's not like this is going to happen 50 times a day, right? It's not like you're going to end up having 50 instances per day or 10 per each team and so on, right? This is something that might happen maybe even a few times a week or a few times a month. And those are the ones you want to respond. But at the same time, your engineering team can still deliver maybe like a part of the continuous delivery, like 100 new releases per day if they want to, without you being the bottleneck for approval and so on, right? So build that automated fashion when the situation is, let's say, blue sky, but have the proper enforcement when the situation is bad. And this is like one of the flows that we put in place with some of our customers. Some of customers want to have, especially like in government, we have some defense customers that want to be like separate environments, to have even like a diode between that artifact, like binary management solution as well, right? But you can also have like a local deployment and so on. And we can play with how your developers can pull these libraries from the internet and automatically go through an approval process before it actually reaches their machines, right? And when they pull, we get notified how we're controlling what's the approval process and so on. And that's kind of what we build as a workflow to ensure that you'll have the full control over that approval process without the engineering work being severely affected. right? And again, depending on the deployment models, depending on how you want to build your infrastructure, this can be like separate environments, like a staging versus a production versus a development, or it can be only one binary management or solution and so on. And that can be a remote repository versus local repository and so on and so forth. But at the end, there is a easier way for you to build that approval process and visibility without asking or without hindering productivity that much. And that's probably the best takeaway from the slide. Now, final thoughts. I think we heard the buzzword way too many times. Shift left, shift left, shift left, right? I worked with release security teams in the past where they're like, I consider all my engineering environment compromised. This is where we hold the line. This is where we want to make sure everything is secure. We are the ones approving every list. Okay, perfect. But why do you want to wait until all that is getting to you? Why do you want your engineering environment to, like, why you accept the engineering environment to be compromised? I respect that you want to put clear guardrails in place before you release something in production or to like your customers, but make sure like the same policies, you can add them early on before they even touching your engineering environment, because they still have access to different keys, different environments, different secrets that might compromise a lot more IP than actually your reputation if you release something malicious, right? So keep that in mind as you're going through this one. That's the entire mentality of like shifting left, that same policies that you want to put before the release, some of them can be shifted left and you can actually do a better job without hindering productivity. Because I think this is the main part, right? Like people want to make sure that these engineers, high-paid engineers are delivering super fast and you're not gonna affect their productivity, and then security come later. No, let's make security part of their workflows. Let's add a security overlay I keep talking about as part of their CI/CD pipelines. Don't wait for the build stage for you to do so, or like kind of ops stage. Now, this is where it's tied into investing that automated supply chain scanning, right? So the moment you're actually building that overlay, you can actually have an automated way and automated control over the entire CI/CD pipeline without actually asking too much from your engineers, right? Like they're not going to have to go and change their build process that much. They're not going to have to go and build their automation scripts and that and so on. If you have an easy way to hook into all those repositories at the end of the day, because all of them are repositories. Being a Git repository, container registry, binary management, you name it, they're still repositories of files that we can hook into and like pull the data from and do the proper analysis. And SBOM is just a starting point, right? When you're building a dish, you have the recipe, but that doesn't mimic the end result, right? It does give you like a high level overview of what you need, right? But not of the health of that outcome. So like think about that way as you're going through this. You can put an SBOM program in place, but make sure you have all the data points you need to ensure the health of that SBOM as well, to ensure the health of those dependencies. Again, it's not just is it I don't know, a known library, but is it properly maintained? Who's maintaining it? What license they have? Is that's what vulnerabilities are attached to it, right? And so on and so forth. Like those are kind of things, malware and so on. Those are kind of things you have to keep in mind, right? And once you build in that, you can actually have truly like secure pipelines that you can build, and you can do another proper analysis at build time. You should definitely do subsequent scans in the future, because at the end of the day, if there's one thing we all know, like whatever is not vulnerable today or not malicious today, potentially might be tomorrow or I don't know, a month from now, and so on and so forth. Vulnerabilities are discovered continuously, even for older versions of software or libraries. So keep that in mind. Just because you're releasing something, you're building something now, the fact that there's no critical vulnerability now doesn't mean that component will not have it necessarily in the future. So you have continuous monitoring and inventory as well. And this is a very hard one to achieve when you have to have collaboration between engineers, DevSecOps, security teams, also vendors and so on, right? There are a lot of chefs in the kitchen, all of them with their own KPIs, all of them with their own deliveries, all of them with their own pressure and pressure points as well, right? And so on. So each of them have things they have to focus on. Security or the secure SDLC is not always top of mind for all these folks. but we need to have them aligned, right? The more you actually have that, again, secure overlay on top of things, the easier it is to get them aligned and just interject when needed, instead of like blocking, or for engineers to see security as a blocker for their processes, right? So keep that in mind as you roll this out. You'll have the visibility, but you can also have the enforcement when it's actually needed. And with that in mind, thank you very much for your time. We'll take I hope we answered all questions in the chat. If not, we can take some of them as well right now. Feel free to reach out to us if you have more questions. And looking forward to see you in the next webinar. Thank you much for your time.